Hi everyone. In today's video, we're going to be making a simple vertical fossil stand for this Pleistocene mammal bone. This thing's pretty cool. It was dredged from the bottom of the North Sea, and we can still see barnacles attached to it. Before we open Tinkercad, we should have some idea of what we want to do. I'd like to display the fossil vertically, so it doesn't take up too much shelf space in my already very cramped displays. For the vertical portion of the stand, I'd like to use a segment from a wooden dowel. This will be stronger than most 3D prints, and will save us quite a bit of print time. For the bottom, I was thinking something like an oval disc with a cylinder to attach the dowel rod, and a lip to prevent the bottom of the bone from sliding forward. This lip could also be used as a label holder if we'd like. For the top, I'm thinking we'll just mount a couple arms coming from a cylinder, which will mount to the top of the dowel. You could add a tiny hole or a groove to the arms and put a thin thread or wire to help support the fossil for if it ever falls forward. But I don't think that's necessary for my purposes. Looking at the vertical cross-section of our fossil, we can think of a good approximate shape to represent it in Tinkercad. In this case, I think a semicircle or a semi-ellipse would work well. Okay, we've opened Tinkercad and renamed our model Pleistocene Bone Holder. I've measured my dowel rod to be 10 millimeters wide at its widest point. We'll make a hole of 10.2 millimeters width to ensure it'll fit without sanding. Note that the amount of sides has been increased to 64. This will also help ensure a better fit. To make the outside of the cylinder that holds the dowel, I'll duplicate my hole and change it to a solid. I'd like the walls of the cylinder to be 2 millimeters thick, so we add 4 millimeters to the total width of our cylinder. I'd like the cylinder to be a total of 10 millimeters in height with a floor 1 millimeter thick. To do this, we resize the height of the solid to 10 millimeters and the hole to 9. Selecting both objects, we use the Align tool to align the hole to the center of our cylinder, and then align to the top of the vertical axis. Grouping them, you can see we now have a capped cylinder. This will be our dowel connection for both the top and bottom parts, so I'll duplicate it now. To keep our duplicate from being in the way, we can press this light bulb button or press Ctrl-H on our keyboard to hide it from our view. Whenever we want it back, we can just press this upper light bulb to make all our hidden objects reappear. Next, I'd like to create an approximation of the bottom of our fossil by adding a semi-ellipse. The approximate width of our fossil is 55 millimeters, and the thickness is about 40. We only need the shape as a reference for shaping the rest of our model, so I'll make it 1 millimeter in height and rotate it to be parallel with the bed. I rotated it the wrong way, but this is a good opportunity to show you the mirror function in Tinkercad. If we press M on our keyboard, we're presented with arrows. Clicking on an arrow will reflect our object across that axis. Now I'll align the fossil so it's centered with our dowel post, and create a floor for our model with the cylinder shape. All we need to do here is reduce the thickness to a couple millimeters, and drag it to cover the approximate shape of our fossil in a way that won't get in the way of our dowel post. I also increased the number of sides for a smoother looking edge, but this isn't necessary. To make a lip that follows part of the circumference of our base, we can duplicate our floor and set it to the height we'd like the lip to be. I chose 10 millimeters, which will give us a lip 8 millimeters above the floor layer of our model. The rest of our base will be in the way, so let's hide it with our light bulb button for now. I'd like this lip to be 1 millimeter thick, so we'll duplicate our layer and change it to a hole. Now we can subtract 2 millimeters from each side, center it, and combine it to create an oblong cylinder. I only want the lip to be on the front of the model, so we can use the square hole to eliminate however much of the shape we'd like to remove. I'll show our hidden shapes by clicking the upper light bulb and combine the dowel cylinder with our floor. Now, being careful not to select the fossil reference, I align the lip with the center and the right edge of the model. Grouping them completes the lower section of our fossil stand. We can hide it and work on the upper section now. For reference, we create another semi-ellipse, this time with a width of 40 millimeters and a thickness of 30 to match our fossil. I'd like to place our rectangular arms in a way that they'd fill part of the hole for the dowel. So I'll ungroup this hole for now, so when we regroup it'll also apply to the parts of the arm that are in the hole. I've decided to make the arms 10 millimeters wide and 5 millimeters thick. Comparing to the scale reference of our fossil and the dowel, I no longer like my original design with the 45-degree angles. Instead, we'll go with 90 degrees on the arms. We can just duplicate this first arm segment and rotate it 90 degrees. I'm just going to eyeball stretching this out to match our cross section. Because our top piece will be symmetrical, we can hide our reference piece and group half of the top. Now we duplicate it and mirror our duplicate by pressing M and selecting the mirror axis. Holding Shift while we drag the model will allow us to move it in a straight line on our work plane. Here I'm trying to drag both pieces so the dowel cylinder is perfectly aligned. Our snap grid is preventing perfect alignment. Turn it off and use the arrow keys on the keyboard to get everything as perfect as possible. We can now group these two shapes, completing the top piece of our model. Now we've 3D printed our parts. First, let's test to make sure the parts fit our dowel. We cut the dowel to an appropriate length and glue our parts into place. Super glue, hot glue, or epoxy will all work fine. Here are a few shots of the finished product. If you've made something cool in Tinkercad or have suggestions for future videos, feel free to comment below.